North Atlantic, early 1942. U-boat wolfpacks, unseen predators in the frigid depths, were systematically dismantling the Allied lifeline to Britain, sinking an average of 100 merchant ships each month. Production logs from American shipyards, compiled in January 1942, showed a glacial pace. A single freighter required approximately 230 days from keel laying to launch. This catastrophic disparity between destruction and construction threatened to starve an island nation and cripple the nascent American war effort before it could truly begin. The stakes were nothing less than the survival of the Allied cause, tethered precariously to the dwindling tonnage afloat. The United States Maritime Commission, tasked with orchestrating the nation's shipbuilding program, found itself facing an existential crisis. Its chairman, Admiral Emory S. Land, a man steeped in traditional naval architecture, understood the gravity but remained bound by established practices. Into this crucible stepped Henry J. Kaiser, a civilian industrialist whose name was more commonly associated with concrete dams and highways than with the intricate art of shipbuilding. His initial foray into maritime construction, driven by a pre-war contract for cargo vessels, had already raised eyebrows among the old guard. Kaiser's early shipyards, particularly those on the West Coast, were a chaotic symphony of activity, yet their output, while increasing, still lagged behind the desperate demand. Traditional shipbuilders, many with generations of craft experience, viewed Kaiser's methods with a mixture of skepticism and disdain. They saw an outsider, a dam builder, attempting to apply mass production principles to an industry built on bespoke craftsmanship and meticulous sequential construction. The prevailing wisdom dictated that a ship was built from the keel up, piece by painstaking piece, a process inherently resistant to acceleration. Examination of standard shipbuilding practices revealed a deeply ingrained sequential workflow. A vessel's hull plates, for instance, were typically cut, shaped, and then riveted directly onto the keel and frames, often in situ on the slipway. This method necessitated a large workforce clustered around a single hull, with each trade waiting for the preceding one to complete its task before beginning its own. Production reports from established yards consistently detailed bottlenecks at the riveting stage, a labor-intensive and time-consuming process requiring highly skilled teams. The quantitative impact of this traditional approach was stark. A typical C2-type freighter, a common design, required upwards of 3 million rivets, each one driven by hand. This translated into hundreds of thousands of man-hours per vessel, dedicated solely to fastening plates, a significant portion of the total construction time. The strategic implication was clear. If the rate of sinkings continued unchecked and shipbuilding remained at its traditional tempo, the logistical backbone of the war would fracture. The quiet reflection among strategists was that the U-boat menace, if sustained, could win the war in the Atlantic without a single shot fired on land. The traditional shipyard, a tableau of painstaking craftsmanship, operated with a singular, unhurried rhythm. A vessel's keel, often a massive timber or forged steel beam, would be laid directly onto the slipway, the very ground upon which it would be constructed and from which it would eventually slide into the water. This foundational act committed the entire project to a fixed location for the duration of its build. Each subsequent frame, plate, and bulkhead was then meticulously installed in sequence, working outwards and upwards from that central spine. This method, refined over centuries, demanded a continuous presence at the slip. Carpenters, riveters, and fitters moved along the growing hull, their work dictated by the ship's increasing structural integrity. The process was inherently linear. One stage had to be largely complete before the next could commence without significant logistical hurdles or safety risks. A detailed production log from the Fore River Shipyard in 1918, for instance, shows distinct phases for hull erection, machinery installation, and outfitting, each consuming weeks or months in isolation. The economic implications of this sequential build were profound. A single slipway, an enormous capital investment, could only host one ship at a time. As one vessel slowly took shape, the slip remained occupied, rendering it unproductive for any other project. This bottleneck severely limited output, irrespective of the available labor force or material supply. The average time from keel laying to launch for a large cargo vessel in the pre-war era, according to contemporary maritime industry reports, hovered around 8 months. The inherent inflexibility extended to labor management. Specialized teams, such as riveters or welders, often had to wait for preceding trades to finish their tasks before they could begin. This created peaks and troughs in demand for specific skills, leading to inefficiencies and often idle time for skilled workers. The entire operation was a delicate dance of coordination, where any delay in one section rippled through the entire construction schedule, pushing back the launch date. Material flow also suffered under this monolithic approach. Components, from massive steel plates to intricate piping, had to be delivered directly to the slipway, often requiring complex maneuvering around the partially constructed hull. Storage space around the slip became critical, and any disruption in the supply chain could bring the entire assembly to a halt. The sheer scale of the vessel under construction dominated the surrounding yard, dictating logistics rather than adapting to them. This deeply ingrained methodology, while producing robust and seaworthy vessels, was fundamentally ill-suited to the demands of rapid wartime expansion. It was a craft, not an industry in the modern sense. The reliance on a singular, fixed point of construction meant that increasing output was a direct function of increasing the number of expensive, sprawling slipways, a slow and resource-intensive endeavor in itself. Richmond, California, 1941. The vast, unyielding demand for cargo vessels choked the arteries of Allied supply, threatening to sever the lifeline to a beleaguered Europe. Traditional shipyards, steeped in centuries of craft, projected build times of 230 days per vessel, a rate utterly incompatible with the 1.5 million tons of shipping lost to U-boat depredations each month. Into this chasm of need stepped Henry J. Kaiser, a man whose empire had been forged not on the sea, but in the concrete and steel of monumental land-based construction, dams, bridges, highways. He possessed no maritime lineage, no master shipbuilder's pedigree, only an audacious conviction that the principles of mass production, honed in the terrestrial realm, could be transplanted, whole and transformative, to the shipbuilding industry. Kaiser's initial proposals, delivered with the blunt force of a man accustomed to moving mountains, were met with a mixture of skepticism and outright derision from the established shipbuilding fraternity. His insistence on welding over riveting, on prefabrication of massive hull sections, and on the assembly line principle, concepts then considered radical, even heretical, in the staid world of naval architecture, challenged every ingrained convention. The traditional method involved laying a keel, then building the ship upward and outward, piece by painstaking piece, often by skilled craftsmen working in cramped sequential stages. This artisanal approach, while yielding robust vessels, was inherently slow, reliant on a limited pool of highly specialized labor. His vision, however, was not merely conceptual. It was rooted in the tangible efficiencies he had observed and implemented on projects like the Hoover Dam and the Grand Coulee Dam. There, the sheer scale of material handling and the coordination of thousands of workers had necessitated a granular breakdown of tasks, a standardization of components, and a relentless focus on workflow optimization. He saw a ship not as a singular, handcrafted entity, but as a complex assembly of interchangeable parts, each capable of being manufactured simultaneously in different locations, then brought together for rapid integration. The steel plates, bulkheads, and deck sections, instead of being shaped and fitted on the slipway, would arrive pre-cut, pre-drilled, and often pre-welded into larger modules, ready for seamless incorporation. The technical examination of his proposed methods revealed a profound shift from craft to industrial engineering. Riveting, a labor-intensive process requiring precise alignment of holes and the hammering of thousands of individual fasteners, was to be largely supplanted by electric arc welding. Welding, though initially viewed with suspicion regarding its structural integrity, offered a faster, more continuous join and required fewer highly specialized hands. Furthermore, Kaiser advocated for the pre-outfitting of these large sections. Engine rooms could be assembled, piped, and wired in separate workshops, then lifted as complete units into the hull. This parallel construction methodology dramatically reduced the time a vessel occupied the precious slipway, the bottleneck of traditional shipbuilding. Quantitative analysis of Kaiser's early trials, even before full implementation, demonstrated a compelling acceleration. Where a conventional yard might employ a few dozen skilled riveters on a single hull for weeks, Kaiser's facilities would see hundreds of welders, often less experienced, working simultaneously on multiple prefabricated subassemblies. The material flow was meticulously choreographed, akin to an automotive assembly line, with components moving progressively through fabrication bays to the final assembly points. This systematic approach, documented in internal production logs, began to show initial reductions in hull construction time from months to weeks, even as the first ships were still being completed. The strategic implication of this industrial reimagining was immense. If Kaiser's methods proved scalable, the United States could potentially overcome the crippling shipping deficit, not merely by building more ships, but by building them faster than the enemy could sink them. This wasn't just about economic output. It was about the very viability of the Allied war effort, the ability to transport troops, tanks, and supplies across vast oceans. The ideological shift was equally profound. It signaled a move away from the bespoke, almost artistic creation of ships, towards a recognition of their role as utilitarian tools, mass-produced instruments of logistical power. The quiet hum of welding torches, replacing the rhythmic clang of riveters, began to echo across the newly constructed Richmond shipyards, a sound that would soon be heard in yards across the nation. The shipyards, sprawling giants of industry, had always operated under a singular, established rhythm. A keel was laid, a frame erected, and then, piece by painstaking piece, the entire vessel was constructed on a single slipway, from bow to stern, deck by deck. This process, honed over centuries, dictated that a ship occupied a valuable slip for the entirety of its construction, a bottleneck that constrained output regardless of how many skilled hands were employed or how much material was procured. It was an immutable law of shipbuilding, as constant as the tides. Henry Kaiser, however, saw not immutable law but an archaic inefficiency. His experience in large-scale construction, dams, bridges, infrastructure projects of immense complexity had taught him the power of parallel processing, of breaking down a monolithic task into discrete, manageable units that could be executed simultaneously. He envisioned a radical departure from the traditional shipbuilding paradigm, a system where the ship itself was not a single continuous build, but a collection of prefabricated modules. Under Kaiser's proposed system, the ship's hull, superstructure, and internal components would be divided into dozens of massive sections. These sections, some weighing hundreds of tons, would not be built on the slipway, but in vast, dedicated fabrication shops, often miles away from the final assembly point. Bulkheads, deckhouses, engine rooms, and cargo holds would emerge from these shops as complete, self-contained units, each a miniature construction project in itself, executed by specialized teams. The implications of this modular approach were profound. Instead of a single ship occupying a slip for 230 days, the slipway would become a mere assembly point, a final stage where pre-built sections were hoisted into place and welded together. This shift meant that multiple sections for multiple ships could be under construction concurrently, not sequentially. The bottleneck of the slipway was effectively dissolved, transformed into a rapid-fire staging area. Production logs from the Richmond shipyards, once Kaiser's methods were implemented, illustrate the dramatic acceleration. The traditional 230-day build time, a standard across the industry, began to shrink with astonishing speed. The first ships built under the new system still took weeks as the workforce adapted to the modularity, but the learning curve was steep and unforgiving. Each completed vessel provided invaluable data, each weld a lesson learned, each lift a refinement of the process. The strategic advantage of this method was not merely quantitative, it was existential. The U-boat menace in the Atlantic was sinking Allied shipping at an unsustainable rate, threatening to sever the vital supply lines to Britain and the Soviet Union. Every lost merchant vessel represented a blow to the war effort, a delay in material, a weakening of the Allied position. Kaiser's system offered a direct counter to this attrition, a means to replace losses faster than the enemy could inflict them. The ship, once a testament to artisanal craftsmanship and prolonged labor, was reimagined as an industrial product, a testament to efficiency and standardized design. The elegance of the solution lay in its simplicity, in the application of mass production principles to an industry long resistant to such innovation. It was a complete reconceptualization of the shipbuilding process, transforming it from a linear progression into a complex, multi-threaded operation. The slipway, once the bottleneck of all shipbuilding, now saw a dramatic acceleration in its utility. Where a hull had previously occupied the precious ground for months, undergoing the slow, sequential accretion of plates and frames, it now received a largely pre-assembled structure in a matter of days. This shift in methodology liberated the slipway from its former role as a primary construction site, transforming it instead into a final assembly point. The modular components, fabricated in parallel across a network of specialized workshops, arrived at the slipway ready for integration. Bulkheads, deck sections, and even entire superstructure units, complete with wiring and piping, were hoisted into position by gantry cranes with practiced precision. This concurrent manufacturing process, a radical departure from the traditional linear build, meant that multiple stages of construction were occurring simultaneously, albeit at different physical locations. Production logs from the Richmond shipyards, for example, documented a staggering reduction in the time a hull spent on the ways. From an average of 230 days in the initial conventional builds, this figure plummeted to an astonishing 56 days by late 1942, and then further still, to an average of just 4 days by mid-1943 for the most efficient yards. This exponential increase in slipway turnover directly translated into a proportional increase in the number of ships launched. The strategic implication of this industrial arithmetic was profound. The Axis U-boat campaign, designed to cripple Allied shipping and starve Britain into submission, relied on sinking tonnage faster than it could be replaced. With the traditional shipbuilding pace, this attrition strategy held a terrifying efficacy. However, the new production rate inverted this equation, ensuring that for every vessel lost, several more were sliding down the ways, ready to join the convoys. This continuous flow of new hulls, a river of steel pouring into the Atlantic, undermined the very foundation of the German naval strategy. The sheer volume of ships, rather than their individual speed or armor, became the decisive factor. It was a victory of industrial scale, a testament to the power of reimagined processes over entrenched tradition. Richmond, California, September 1941. The SS Patrick Henry, the first of the emergency program cargo ships, slid down the ways at Bethlehem Steel's Fairfield Yard after 244 days of construction, a testament to traditional shipbuilding methods. Her launch marked a significant achievement, yet the pace was far too slow for the gathering storm. The sheer volume of material and personnel required to bring a single vessel from keel laying to sea trials represented a bottleneck that threatened to cripple the Allied war effort before it truly began. The stakes were immense. Without a rapid, sustained flow of cargo ships, the transatlantic lifeline would fray, and Britain, isolated and besieged, would fall. The Kaiser Permanente Metals Corporation, under Henry J. Kaiser's relentless drive, embraced the prefabrication and assembly techniques that had revolutionized other industries. His shipyards, particularly the Richmond facilities, became the proving ground for these radical ideas. Instead of building a ship in one location, piece by piece, the vessel was broken down into hundreds of large, pre-welded sections. These sections, some weighing over 100 tons, were fabricated in workshops, often miles from the slipway, and then transported by rail or barge to the assembly point. This modular approach allowed for simultaneous construction of different parts, dramatically compressing the overall timeline. Detailed production logs from the Richmond No. 2 yard reveal the accelerating pace. The first ship built under the new system at that yard, the SS Ocean Vanguard, required 105 days from keel laying to launch. This was a substantial improvement over the Patrick Henry's 244 days, but it was merely the beginning of the true transformation. The process was continuously refined, with every bottleneck identified and eliminated. Cranes were repositioned, welding techniques optimized, and worker teams specialized in single, repetitive tasks, fostering an almost industrial rhythm. The SS Robert Peary, launched in November 1942, became a stark demonstration of the system's ultimate potential. From the moment its keel was laid to its triumphant launch, a mere 4 days and 15 hours elapsed. This astounding figure, recorded in the yard's official launch reports, was not an anomaly, but a benchmark. The Peary was not an empty hull, it was a fully fitted vessel, ready for its final outfitting and sea trials, a process that itself had been streamlined. This single event, widely publicized, sent a clear message across the nation and to the Axis powers. American industrial might was not just awakening, it was operating at an unprecedented, almost unbelievable speed. The implications extended far beyond mere shipbuilding records. Each Liberty ship delivered represented 10,000 tons of vital cargo capacity, capable of transporting tanks, aircraft, ammunition, and food across dangerous ocean lanes. The ability to produce a vessel in less than a week meant that losses to U-boat attacks, though still severe, could be rapidly replaced, preventing the cumulative attrition that Germany had hoped would cripple Allied logistics. This sustained output effectively neutralized the U-boat threat by overwhelming it with sheer numbers, ensuring the continuous flow of supplies essential for prosecuting a global war on multiple fronts. The rapid construction of these ships became a silent yet powerful weapon in itself, fundamentally altering the strategic balance of the war. The Richmond shipyards hummed with an almost unnatural efficiency, a testament to the integrated system now fully operational. Hull plates, once individually cut and shaped at the slipway, arrived prefabricated from inland steel mills, their edges already beveled for welding. Subassemblies, some weighing over 100 tons, were hoisted into place by gantry cranes. Their precise fit a direct result of the meticulous planning and standardization that preceded their arrival. Production logs from the Kaiser Permanente Metals Corporation's Richmond No. 2 shipyard indicated a stark transformation in output. Whereas the initial goal of a single Liberty ship had been projected to take 230 days, the application of Kaiser's prefabrication and modular construction methods had systematically whittled away at that timeline. By late 1942, the average construction time for a Liberty ship at Richmond No. 2 had plummeted to 56 days. This acceleration was not an isolated incident, but a consistent trend across all Kaiser yards. The systematic breakdown of the shipbuilding process into smaller, manageable, and parallel tasks allowed for a continuous flow of work, eliminating bottlenecks that had plagued traditional methods. Welding, once a slow, individual craft, was now a synchronized ballet of multiple teams working simultaneously in different sections of the hull. The most dramatic demonstration of this efficiency came in November 1942, when the SS Robert E. Peary was launched from Richmond No. 2. From the laying of its keel to its launch, the entire process took a mere 4 days and 15 hours. This feat, widely publicized, became a symbol of American industrial might and ingenuity, a stark contrast to the months-long construction times of earlier vessels. This unprecedented output fundamentally altered the strategic landscape of the war. Production records from the U.S. Maritime Commission showed that by the end of 1943, over 1,400 Liberty ships had been delivered, a rate that far outstripped U-boat sinking rates. The sheer volume of these vessels ensured a continuous supply line to Allied forces across the globe, negating the German submarine campaign's effectiveness. The ability to replace losses almost as quickly as they occurred, and then to vastly exceed them, allowed for the sustained projection of American power. The logistical demands of a global conflict, once a seemingly insurmountable challenge, were now being met by an industrial machine operating at a scale previously unimaginable. The steady stream of these utilitarian vessels, often derided for their simplicity, became the very sinews of war. The shipyards, once a collection of disparate crafts, had been re-engineered into a synchronized industrial ballet. Kaiser's methods, initially viewed with skepticism by established shipbuilders, had proven their undeniable efficacy through sheer output. The prefabrication of hull sections, the assembly line approach to fitting out, and the systematic training of a diverse workforce had fundamentally reshaped the very definition of maritime construction. This transformation extended beyond the physical assembly of ships. It permeated the organizational structures and management philosophies. The traditional artisan-led model, where individual craftsmen oversaw large portions of a vessel's construction, yielded to a highly standardized, process-driven system. This new paradigm emphasized interchangeable parts, specialized labor, and continuous flow. Principles previously honed in automotive and other mass-production industries. The quantitative impact was stark. Production logs from the U.S. Maritime Commission documented the average construction time for a Liberty ship plummeting from 230 days in early 1941 to an astonishing 4.2 days by late 1943. This exponential acceleration was not merely an incremental improvement. It represented a complete reimagining of industrial capacity, turning a bottleneck into a torrent. The strategic implications of this output were profound. The relentless U-boat campaign, which had threatened to sever the Atlantic lifeline, found itself overwhelmed by the sheer volume of replacement tonnage. For every ship sunk, multiple new vessels were launched, ensuring the uninterrupted flow of materiel and personnel to the European and Pacific theaters. This